The Sun contains 99.8% of the solar system's total mass, making it an overwhelmingly dominant force. What if, in a cosmic twist, it absorbed Jupiter, the largest planet in our solar system? This intriguing scenario raises questions about the potential impact on the Sun's behavior and the rest of the solar system. Would Jupiter's addition change the Sun's structure or lead to significant solar activity? Join us as we explore the fascinating possibilities and potential consequences of this cosmic event. What do you think would happen? Our solar system is dominated by the Sun, a colossal ball of hydrogen and helium gas that dwarfs all the planets combined. The Sun's immense gravity and energy are the driving forces behind the orbits of the planets, comets, and asteroids. But among the planets, Jupiter stands out as a giant in its own right. With a mass more than 300 times that of Earth and a diameter over 11 times larger, Jupiter is a gas giant, composed primarily of hydrogen and helium, much like a miniature star that never ignited. Now, imagine if this gas giant, Jupiter, were to be pulled into the Sun. As Jupiter approaches the Sun, the gravitational forces at play would be intense. However, despite its size, Jupiter's mass is only about 1/1000th of the Sun's mass. This means that while the Sun would gain mass from absorbing Jupiter, the overall impact on the Sun's structure and behavior would be surprisingly minimal. One of the immediate effects of Jupiter's plunge into the Sun would be an increase in solar activity. The addition of Jupiter's mass, composed mainly of hydrogen and helium, could cause localized disturbances in the Sun's outer layers. This might result in solar flares and coronal mass ejections as the Sun releases the sudden influx of material. These events could temporarily increase the amount of radiation and charged particles emitted from the Sun. On Earth, these increased solar emissions could lead to stronger auroras and potential disruptions to satellite communications and power grids. However, these effects would be short-lived as the Sun would quickly stabilize. It's important to note that the Sun, with its immense energy output, constantly undergoes processes that dwarf the addition of even a massive planet like Jupiter. To put things into perspective, the Sun converts about 600 million tons of hydrogen into helium every second, releasing an incredible amount of energy. The addition of Jupiter's mass, while significant on a planetary scale, is relatively negligible compared to the Sun's overall mass and energy budget. The Sun's core, where nuclear fusion occurs, would remain largely unaffected by the added mass, and the Sun's lifespan and evolution would continue as if nothing had happened. While the event of the Sun swallowing Jupiter would be a momentous occurrence in our solar system, its long-term effects on the Sun and the rest of the solar system would be minimal. The Sun's vast size and energy capacity allow it to absorb such an addition without significant change. This scenario underscores the sheer scale of our star and the dynamic, yet stable, nature of our solar system. In the grand scheme of things, the Sun would continue to shine, and the orbits of the remaining planets would remain largely unchanged. This thought experiment not only highlights the impressive characteristics of both the Sun and Jupiter, but also the incredible balance that exists in our cosmic neighborhood. While the Sun's mass and overall energy output would remain largely unaffected, the absorption of Jupiter could have subtle effects on the solar system's dynamics. Jupiter's massive gravitational influence has shaped the orbits of many objects, including asteroids and comets, as well as playing a role in stabilizing the orbits of the inner planets, including Earth. As Jupiter is absorbed by the Sun, its gravitational pull would no longer influence the surrounding space. This could lead to minor shifts in the orbits of asteroids in the asteroid belt and potentially in the orbits of the inner planets. However, these changes would be minimal, given the vast distances involved and the stabilizing effects of the Sun's overwhelming gravity. Despite these potential shifts, the solar system would remain stable. The planets, including Earth, would continue to orbit the Sun much as they did before. The loss of Jupiter might result in a slight decrease in the gravitational shielding it provides, which helps deflect comets and asteroids away from the inner solar system. However, the likelihood of a significant increase in impact events on Earth would still be low, given the vastness of space and the numerous factors that influence the paths of such objects. The absorption of Jupiter also wouldn't alter the Sun's life cycle. Currently, the Sun is in its main sequence phase, where it fuses hydrogen into helium. The Sun, a middle-aged star, is currently in a stable phase known as the main sequence, where it has been for about 4.6 billion years. This phase, where the Sun fuses hydrogen into helium in its core, will continue for approximately another 5 billion years. Following this period, the Sun will evolve into a red giant, expanding significantly and eventually shedding its outer layers. What remains will be a white dwarf, a dense and cooling remnant of the Sun's former self. The hypothetical scenario of the Sun swallowing Jupiter, while dramatic, would have relatively minor implications for the solar system. Jupiter, the largest planet in our solar system, is about 1,000th the mass of the Sun. Adding Jupiter's mass to the Sun would slightly increase its total mass, but this change is negligible in terms of the Sun's overall mass and the dynamics of its life cycle. The Sun's evolution and eventual fate are governed by the nuclear fusion processes occurring in its core and its overall mass. The core processes are responsible for the Sun's luminosity and heat, driving its expansion into a red giant in the future. This massive star's behavior is influenced more by its intrinsic properties than by the addition of a planet's mass. Therefore, the solar system's grand trajectory, including the timing of the Sun's transformation into a red giant and its subsequent cooling into a white dwarf, would remain largely unaffected. Despite the seemingly minor impact of such an event, it highlights the remarkable stability of our solar system. The interactions between celestial bodies, while dynamic, do not disrupt the fundamental balance that has allowed the solar system to thrive for billions of years. The Sun, in its powerful and consistent energy production, continues to sustain the planets in their orbits, guiding them on their cosmic journey. This thought experiment also serves to underscore the vast scales and forces at play in our universe. From the gravitational forces that govern planetary orbits to the nuclear reactions that fuel stars, the interactions between these cosmic elements create a dynamic environment. Even the largest planets, like Jupiter, are small compared to the grand scale of stellar evolution. As we delve into these cosmic scenarios, we gain a deeper appreciation for the intricate balance that maintains the stability of our solar system and beyond. The Sun's story, from its formation to its eventual transformation, exemplifies the ongoing processes that shape the universe. If you enjoyed this exploration of cosmic possibilities, don't forget to like and subscribe for more captivating content about space. Share your thoughts on other cosmic scenarios that fascinate you in the comments below.